So the question I got for this math assignment was question 9 on November 2010, paper 1, and it's pretty much dealing just with functions and subbing them into each other and trying to find points where they intersect. So we are given the two functions f at x equals x squared plus 4 and g of x equals x squared minus 1 right here. There's f of x, there's g of x. And we are asked to answer a bunch of questions about this function. So let's start off with find f of g of x. So to start off with this, what you have to do is you have to take the g function, which is x minus 1. Let's get some, so you take the g function, which is x minus 1, and sub it into the x of the f function. So by doing that, we get the equation f of g of x is equal to x minus 1 squared plus 4. And now we just expand the brackets, so FOIL the x minus 1 to get x squared plus 2x plus 1, and then add the 4, and we are left with the final equation of x squared minus 2x plus 5. And that's your f of g of x equation. So the next question tells us that the vector of 3 minus 1 translates the graph of f of g to the graph of h. So what this means is that the graph is moved 3 units to the right and 1 unit down. So finding these coordinates are very easy because we already have the normal equation right there of x minus 1 squared plus 4, and all we do is we add 3, we take away 3 from here because it's moving to the right, so you have to subtract 3, and it's moving 1 down. So by doing that, we are left with the equation, or the vertex of h being at 4, 3, which is a pretty simple question. The next question asks us to show that h of x is equal to x squared minus 8x plus 19. Right? So now that we have the vertex for h, we can sub it into the normal equation of x minus the horizontal translation plus the vertical translation. And since we now have the point of x and y, we can sub it into our equation to grant x minus 4 squared plus 3, right? Because there's the 4 to the right giving us the x coordinate of 4, and there's 3 up giving us the y coordinate of 3. So now again we just FOIL the x minus 4 squared and add 3 in the end, so we get x squared minus 8x plus 16 plus 3, which leaves us with x squared minus 8x plus 19. Now the last question, D, is telling us that we have a tangent point of y equals 2x minus 6. And that intersects the line, our curve at point P. So just to give you a little graph of what this might look like, so here we have our axes, and just randomly, here's our graph. It's going to be concave, it's going to be up, and it's going to look like that, somewhere, whatever. And now we have the point of y equals 2x plus 6 minus 6 coming through our line somewhere, and at that point right there, we are going to get point P. Point P. There we go. So all we have to do this is state that h of x is equal to y, which is 2x minus 6. So now we sub these in, so h of x, x squared minus 8x plus 19 equals 2x minus 6. We rearrange, so we move the 2x over to this side, and we move the minus 6 over to this side. So we subtract 2x, giving us negative 10x from 8x, and we add 6 to 19, giving us 25. So now we can factor that function to give us x minus 5 squared, and to find the x coordinate of where this intersects, we just take when this is equal to 0. And that happens to be at x is equal to 5, and since we are asked to find the x coordinate of P, P is equal to 5. I hope this has been an informative learning and answering of question number 9 on November 10, paper 1.